Have you ever gazed up at the night sky, awestruck at the sight of the twinkling stars and the glowing planets, and wondered why you can't see all the planets from Earth? A question that has sparked curiosity in the minds of skygazers, young and old, for countless generations. It's a question that tugs at the very fabric of our fascination with the cosmos. The universe, in all its infinite wonder, holds secrets that we are yet to fully unlock. One such secret lies in the realm of interplanetary visibility. As we stand on our blue marble, gazing into the cosmic abyss, we are only privy to a limited view of our planetary neighbors. But why is that so? What cosmic curtain prevents us from witnessing the full planetary ensemble in all its celestial glory? The answers to these questions are as intriguing as they are elusive. So, fasten your seatbelts, folks. Prepare to embark on a fascinating journey that will unravel the mystery of interplanetary visibility. To understand the enigma of interplanetary visibility, we first need to grasp some basic concepts of space and astronomy. Let's start with the solar system, our cosmic neighborhood. It's an enchanting dance of celestial bodies, all swirling around a single star, the Sun. At the heart of the solar system, the Sun's gravity keeps all the planets in their orbits. Now picture the planets, spinning like tops on their axes, each at their own pace. This rotation is what gives us day and night here on Earth. But remember, each planet has its own unique spin. A day on Venus, for instance, lasts longer than its year. Speaking of years, let's talk about revolution, the journey of a planet around the Sun. This orbit defines a planet's year. And just like rotation, the time it takes to complete this cosmic circuit varies from planet to planet. For instance, while Earth takes 365 days to orbit the Sun, Neptune takes a whopping 165 years. These orbits aren't perfect circles, but rather ellipses, stretched out circles. This means that planets aren't always the same distance from the Sun or from each other. And this, my friends, is where visibility comes into play. Visibility is all about light, specifically sunlight. The sun's rays illuminate everything they touch. But space is vast, and not all light reaches us here on Earth. The distance a planet is from us, its position relative to the sun, and its own rotation and revolution all affect how much sunlight it receives and therefore how visible it is from Earth. So when you gaze up at the night sky, remember that you're not just looking at stars. You're witnessing a cosmic ballet of planets spinning and revolving, bathed in sunlight and shadow. And the visibility of these celestial bodies is not just a question of light and shadow, but a complex interplay of distance, position, and motion. With these basic concepts in mind, we are now ready to delve into the mystery of interplanetary visibility. Several factors determine whether we can see a planet from Earth. Firstly, let's talk about distance. Just like how you'd struggle to see a friend waving from the other side of a massive field, the further away a planet is from Earth, the harder it is to see. This is why we can see planets like Venus and Mars quite clearly, as they are our closest neighbors, while Neptune and Pluto, being the furthest, are a lot trickier to spot. Next up, we have the size of the planet. The larger the planet, the easier it is to see. Jupiter, the largest planet in our solar system, can be seen from Earth with the naked eye. However, smaller planets like Mercury can be harder to spot, despite being closer to us than Jupiter. The third factor is brightness. Planets do not have their own light source, they reflect the light from the Sun. The more light a planet reflects, the brighter it appears to us. Planets with thick atmospheres or reflective surfaces like Venus are easier to see because they reflect a lot of sunlight. On the other hand, planets with darker surfaces like Mars reflect less light and are therefore less visible. Finally, the time of observation also plays a crucial role. Some planets are only visible during certain times of the day or year. For instance, Venus is often referred to as the morning star or evening star because it can be seen from Earth just before sunrise or just after sunset. So to sum up, the visibility of a planet from Earth is determined by its distance from us, its size, its brightness, and the time of observation. Understanding these factors helps us comprehend why some planets are easily visible while others remain elusive. Now that we know the factors that determine visibility, we can begin to understand why we can't see all the planets from Earth. Despite our advances in space exploration, there are still some planets that remain hidden from our view. This is the dark side of interplanetary visibility, a fascinating aspect of space exploration that continues to intrigue scientists and space enthusiasts alike. Let's start with distance. It's no secret that space is vast, incredibly vast. The distances we're talking about here are so immense that they're measured in light years. That's the distance light travels in a year, which is almost 6 trillion miles. Now imagine trying to spot something as small as a planet from billions of these miles away. It's akin to trying to spot a single grain of sand on a beach from miles away. Next, let's talk about size. Planets like Earth or Mars may seem huge to us, but in the grand scale of the universe, they're actually quite small. The larger a planet is, the more light it reflects, and hence the easier it is to see. Smaller planets, however, reflect less light and are therefore harder to spot. Then there's the matter of brightness. This is determined by a planet's albedo, or how much light its surface reflects. Planets with high albedo like Venus or Jupiter are relatively easy to see because they reflect a lot of light. But planets with low albedo like Mercury or Mars reflect less light and are therefore harder to see. Lastly, the time of observation plays a crucial role. The best time to observe a planet depends on its position relative to the Earth and the Sun. For instance, planets are usually most visible when they're in opposition or directly opposite the Sun from Earth. However, this alignment doesn't happen often. For Mars, it occurs only once every 2 years, while for outer planets like Jupiter and Saturn, it happens roughly once a year. So, as you can see, there's a complex interplay of factors that determine whether or not we can see a particular planet from Earth. And while our technology continues to improve, allowing us to peer deeper into the cosmos, there are still limitations. There are still planets that remain hidden from our view, shrouded in the cosmic darkness. The dark side of interplanetary visibility is a compelling reminder of the vastness of space and the many mysteries it still holds. It's a testament to our human curiosity and our relentless pursuit of knowledge. After all, what's more exciting than a mystery waiting to be solved, a secret waiting to be uncovered? So, as we continue to explore the cosmos, we can look forward to uncovering more of these hidden gems, to shedding more light on the dark side of interplanetary visibility. Space exploration is a journey of discovery, and the mystery of interplanetary visibility is just one of the many enigmas that we are yet to solve. Our cosmic journey has taken us through the basics of space visibility, the factors that determine it, and the dark side of interplanetary visibility. We've learned that space isn't just a vast expanse of emptiness. It's filled with cosmic dust, gas, and other interstellar medium that can affect how we perceive celestial bodies from Earth. What's more, the rotation and tilt of our planet, the orbits of other celestial bodies, and even our own atmosphere can all affect our ability to see other planets. We've also discovered that light, the very tool we rely on to observe the universe, can sometimes be our own worst enemy. Light pollution, glare, and the bending of light can distort our view of the cosmos. Why does all this matter? Well, understanding visibility in space is crucial for both amateur stargazers and professional astronomers. It can help us plan when and where to look for planetary alignments, meteor showers, and other celestial events. Plus, it can inform the design of telescopes and other observation equipment to minimize distortion and maximize clarity. But perhaps most importantly, it reminds us of the vastness and complexity of the universe. It's a humbling reminder that there's so much more to learn, so many more questions to ask. As we push the boundaries of our knowledge and technology, the final frontier of space continues to beckon. inviting us to unravel its mysteries. Each new discovery, each answered question, only leads to more questions. And that's the beauty of it. The journey of exploration and discovery is endless. We may not have all the answers yet, but every step we take brings us closer to understanding the cosmos and our place within it. So, what's next? Only time and continued exploration will tell. As we continue to explore the cosmos, who knows what other secrets we will uncover? Stay curious, stay fascinated, and keep looking up.